Welcome everyone to this new video. Now we are going to find from this video. Now in our previous video we have derived three things for a projectile motion: height, time and range. Now in this video we are going to find the value of the theta for which you will get the maximum range, and what will be the equation of the path in which that object will move. So these two things we are going to find in this video. Those who are watching this video first time, please go and watch the first part, then come to this video. Now to find the maximum range, we have already derived the formula for the range. The formula for the range is that R is equal to U square sine 2 phi divided by G. So this is the formula for the range. Now what will be the value of the phi for which this R will be maximum? So now for a particular value of U, what will be the value of phi for which this range will be maximum? So you can clearly see that the value of sine theta will be maximum if this 2 phi is equal to 90 degree. That means if 2 phi is equal to 90 degree, then this total value will be maximum for a particular U. Now what will be the value of phi? So that is 45 degree. So if you throw a particular projectile with a 45 degree angle, then with that initial velocity you will get the maximum range when you throw that projectile with an angle of 45 degree. That is the maximum range for a projectile. So now if you place this value in that equation, then what you will get? R equal to U square into sine 90 degree divided by G. That means R will be U square by G. So this is the maximum height you will get with this velocity. So this is the maximum range you will get. Okay, now let us move to the equation of that path. To find out the equation of the path, first you need two things. The first one is how much vertical height it will be displaced in time t, and how much horizontal displacement will be there for a given time. So these two things you will need. First thing, what is the value of y if you are given the t, that means time? Then you can write that, and what is the vertical velocity? Okay, now what is the vertical velocity? Vertical velocity is u sine phi into t minus half g square. Now this equation we get from that equation, a is equal to ut plus half at square. So this is the equation by which you will get the displacement in the vertical direction. Okay, now what will be the displacement in the x direction? The displacement in the x direction will be simple, that x will be u cos phi into t. So these two things you will need to find out this equation of this path. Now what you have to do? You have to do just one thing. Just take the value of t from this equation and put that value in this equation of y. Now y equal to u sine phi. Now what is the value of t from this equation? The value of t from this equation is x divided by u cos phi minus half g t square, that means x square divided by u square cos square phi. Now you get the equation of the path. Now if you little bit simplify it, then you will have the equation. Then y equal to, now this u and this u will be cancel out, then you will get tan phi from here, tan phi into x minus half g by u square. What is the value of 1 by cos square phi? It is sec square phi. That means sec square phi into x square. Okay, so let's do the next step. Y equal to x tan phi minus half g by u square. The value of sec square phi is equal to 1 plus tan square phi. 1 plus tan square phi into x square. But now this is the desired equation we are finding. Now from this equation you will get the value of y for a particular value of x. That means if you select any particular value of x from this axis, then you will get the particular value of y for that x if you put the value of x in this equation. So hope you understood these two things, the maximum range and the equation of the path. So see you again in our next video. Thank you everyone.